So let's talk about artificial intelligence. And by now, you would have a better idea about AI because of the previous talk. So you might think of AI as something like Terminator, Skynet, right? It could be something as sinister as that, or it could be something very simple. Remember back at the uh, this was 2017, I believe, from the Silicon Valley series, and they created this application called Hotdog or Not Hotdog app, and it's that simple. It's just a computer vision system that tells you if what it's seeing is hot dog or not hot dog. That's really it. But at that time, this was big. Nowadays, you would expect more from AI, right? Because of ChatGPT and whatnot. But back then, this is already very good enough. So it could be something as simple as that. There's also this AlphaGo. Are you guys aware about this? What AlphaGo is? So AlphaGo is one of the models developed by Google, and it was able to defeat the best Go player on Earth, Lisa Doll. Now, if you're not familiar, Go, maybe we could say it's just a more complex version of chess. And you know, chess. Chess is also very complicated. And the number of combinations that you have in the game of chess is higher than the estimated number of atoms in the universe. So it's that complex, and we're able to create an AI model that beats the best Go player on Earth. Yeah, so those are some of the applications. So more applications of AI. There's face detection. It's very common these days. One notch higher would be object detection. So instead of just static images, you have moving ones. This is a video. Oh yeah, I mentioned earlier about something like this. Yeah, I've created an app. This was 4 years ago. Yeah, more than 4 years ago, and just detects me and the temperature. So it has hardware, software component, AI, everything. Created my web app. Also, I built my custom hardware for this using RFI, and of course had to tweak the sensors and whatnot. So you could do those things with AI. For self-driving cars, getting more common these days at Tesla. And okay, what else? More use cases, clustering. So in clustering, you're basically just identifying different clusters. This is more specific use case here is topic modeling. So understanding the sentiments of people in an area. Specifically, this is in Makati back in 2018, and I've done this study. Yeah, generative AI. You are supposed to hear Barack Obama, obviously. Great, great, great.
We're entering an era in
Yeah,
which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. President Trump is a total and complete dipshit. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele.
so this is deep fake. Of course, maybe by now a lot of you have seen this, but this technology was released back in, I believe, 2018, roughly 2018. So has existed for quite some time already, way before ChatGPT. Trying to go to the next one. Okay. Of course, there's ChatGPT. I was talking about ChatGPT. Everyone would know about ChatGPT, and it's well the most downloaded application now, and it only took 2 months to get to 100 million global monthly active users, even faster than your popular social media applications. Yeah, and of course, you know what ChatGPT is able to do. Like, so many use cases, can even apparently like get an MBA and all sorts of stuff. Yeah, another application of generative AI, right? So you could also create these images. Looks real, but of course they're not real. So of course this is the image of a pope, but um, doing DJ stuff, and we know that it's not real. So could use Midjourney for that if you haven't heard of that. So these are some sample images that you could generate with Midjourney. Yeah. Oh, actually, this was an AI generated image of me, apparently, created by some of my students. Did it for fun. I think they fed my profile pictures, and I guess in the past couple of months, years, most of it are from Japan. So I guess that's why it looked like this, because I normally go to Japan. Most of my profile pictures are in Japan. Yeah, actually, it's also Japan. So with the ChatGPT 4.0, we could actually do this, which is cool, right? And the description is actually accurate. I was even surprised that it was able to um, determine that I was in Tokyo, specifically this one, suggesting it could be a major metropolitan city, possibly Tokyo. Very cool, right? Anyway, so you've seen various applications of AI, and there's so many. And it's also explained earlier what AI is, but I'll be reiterating that. So, in my own words, I would say AI, or artificial intelligence, is simply the computer simulation of human intelligence. Whatever it is that we normally attribute to humans, if we can put it to machine, then that's AI. If we can, what are the things that we normally do? Let's think of something very simple. If I see this object and um, for example, I'm seeing a table right now. Is this a table or not? I say this is a table. So if I could put that knowledge to a machine or that capability to a machine, then that's AI. It could be something as simple as that, or something more complex, right? Doesn't have to be complex all the time. It can be very simple. So that's AI. And as mentioned earlier, it started in the 1950s. A subset of AI would be machine learning. And in machine learning, we make use of lots of data, and ideally, the machine will be able to identify the pattern on its own, even if we don't explicitly hard code the rules for it. That's the idea with machine learning. So, given lots of data, it will automatically identify the mapping, the pattern on its own. And more specific field would be deep learning. It's under machine learning. So, in deep learning, it specifically uses neural networks. And neural networks are loosely patterned after the human brain. And most of the advancements in the AI field are driven by deep learning based systems. So, to summarize things, AI is the um, umbrella topic. It covers all of these things. It's a superset. Machine learning is a subset of AI, and it's specific to those algorithms that automatically identify the pattern on its own, and deep learning focuses on neural networks specifically. So why is AI booming these days, right? It has been here since the 1950s, but it's only just a few years ago when people are normally talking about AI. It's getting so much hype. So one of it would be data. And I'm pretty sure you've heard of this phrase somewhere for so many times already, that data is the new oil. Why is data the new oil? Well, much like oil, you need to process it, you need to refine it for you to get something out of it. In its raw form, it's practically trash. You need to do something. And another analogy that you could make with data and oil is that back in the days, the oil companies would be your top companies, they're the richest companies. Nowadays, it's data companies such as Google, Facebook. So we're talking about data, right? It also helps that the data that we have is exponentially increasing. So, well, this was done many years ago, but it was projected that we'll have about 175 zettabytes of data by 2025. So, what is a zettabyte? It's just a very big number. It's 1 billion, that's 1 trillion. And remember, I mentioned earlier that in machine learning, we need lots of data. So, it helps that we have more data. That generally means better ML models. But of course, in some cases, it plateaus, of course, like many things. There's diminishing returns. But we have more data. And as engineers, you would know about this, right? Moore's law. So what is Moore's law? It is the empirical observation that the number of transistors doubles every 2 years. And back in the 1970s, you only have a few thousands of transistors in a single chip. And you guys know transistors. But these days, you have so many transistors in a single chip. So billions. Um, and that means better computational power because you have more transistors in a single chip. But you also know that we're hitting the limits. It no longer applies now. It's no longer that linear because of physical constraints. The size of the transistor right now is very small. I believe the commercially available ones would have about 1 to 2 nanometers. And the size of the biggest atom that we have is about zero point 0.3 nanometers. So we're hitting the limits now. Maybe there's another way of doing things, but that's another problem. But this basically means that we have better machines now, and better machines would mean better AI systems. So again, I've mentioned data and then hardware. Finally, there's algorithms research. There's so many algorithms in the field of AI, but one of the ones that I would say is very critical or very important in the field of AI would be AlexNet. Of course, you could argue that it could be any other algorithm, but I believe this is one of the algorithms that started the hype again. There was an AI winter, um, and it happened because AI research cannot meet the expectations of the society. AI has been here since the 1950s, but with this paper back in 2012, the people started to see that AI is working. So in this paper, they were able to create an image classification system that was able to beat the next best performing one by a large margin. And the error here is something that is comparable to human levels. And they're also able to utilize GPU here. So I believe during this time, it started the hype in AI again. And there's so many. Of course, there are more important ones, you could argue, like the back propagation from Geoffrey Hinton, right? Very, very important because it's the foundation of many neural network algorithms that we have right now. It is really the core of neural network, the back propagation, and many other algorithms like generative adversarial nets. And that's more important these days with the hype in generative AI. And of course, what else? The transformer architecture, and so much more. But to summarize things, so here are the reasons why there's an AI resurgence. First is data, then hardware, then research. So let's try to quickly give you a crash course on machine learning. So machine learning is the ability of computers to learn without being explicitly programmed. So if I show you this image, what is this? You would say that this is probably a cat, right? If you see this image, you'd say that this is a dog. But if you see this image, what is it? What do you think? It's, well, most people would say that this is a cat, right? Why? Why do you think this is an image of cat? Would be better if you could share your thoughts about this, but I don't think that this could speak. Anyway, um, so most would say because I'm seeing the features of a cat, but how did you know the features of the cat, right? Because you've seen this many times. You've seen thousands of images of the cat. And because of that, now you know if you see this is a cat. Same thing with machine learning. You feed it with so many examples, so many data points, up until it can now identify something. And there are different types of ML. There's supervised and reinforcement learning. We normally focus on supervised because it is the easiest one, and most of the use cases are out there would be supervised learning. So what is supervised machine learning? So you have your inputs and you have your outputs or target. And the idea is you want to map the two. You want to create this a mapping function that converts the input to the output. That's simply it. Like, what is this thing in between that can do that? What is this equation that can satisfy that? So if I show you this, if I show you these numbers, this is the input and this is the output. What is this thing in between? What is this equation that can satisfy this? I'll give you some time to think about it. So it's a simple one. It's just 2.2 times the input. So it's kilograms to pounds. But what if I show you this thing? You have this input, then you have this output. What is the mapping function? It is a bit more complicated. It's just the Fahrenheit. But the main idea here is that if you have your input and you have your output, um, we should be able to identify the mapping function between, as long as, of course, there's really an actual mapping between the two. And you could use any machine learning algorithm. Could be KNN, could be linear regression, could be support vector machines, could be neural networks, and could be any ML model. And we're not limited to just numbers. It could be images, right? This is an image of a dog, and you can map it. You have this input, and then you have this target, and then use some machine learning model, and it can map the two. That's the idea. Or it could be text. At the end of the day, they're actually all numbers under the hood, but you get the idea. So it could be any other input. Could be any format that you could think of. Could be text, could be image, could be sound, could be your typical numerical data, could be anything. So here are the types of problems that you have in supervised machine learning. So there's classification and regression. In classification, you pick one of the n labels. So here are some examples. Could be a cat, dog, horse or bear, or a male or female, or pass or fail. That's classification. In regression, you predict numerical values. So examples of that would be click-through rate, stock price, power demand. So in regression, again, more examples. So let's say I wanted to predict the temperature in Celsius. It simply use the cricket trips per minute, and it's more or less linear. So if I have about like say 75 cricket trips per minute, that would mean the temperature is 15 degrees Celsius. Something like that. Yeah, it also do our demand forecasting, supply, and prices, all of those things. For classification, again, it's picking one of the N labels. So this is a common data set in machine learning. It's the Satoshi flower data set, and it uses four features, but in this case, I'm just showing you two one. So the sepal with the sepalin, and with that, you could identify the class of the flower. Of course, there are some classifications here, but the idea is that if you have these features, then you would say that okay, this is the class. I'm um, blue class. Forgot which flower the blue represents, but like it could be like the blue or the brown one. So that's classification. Here are some popular ML algorithms. So there's naive Bayes, k-nearest neighbors, logistic regression, support vector machines, decision trees, and neural networks. And use different algorithms for different problems. And if your data is linear, then you would use a linear model. Of course, you could use other ones as well. But If you know it's linear, then use linear logistic regression or SVM. If you're handling image data and the problem is computer vision or image processing, then you use CNN or convolutional neural networks. If it's sequential data, then use LSTM transformers. These days, it's mostly transformer based. If what you want is model interpretability, then you use decision trees, random forest, based linear models. For clustering, use k-means. Uh, if you want accuracy, then there's ensemble algorithms and neural networks. Again, different algorithms for different problems. So in machine learning, you have the following prerequisites: programming, statistics, probability, calculus, and linear algebra. It's best that you have a good foundation on those things, ideally. So how do we do machine learning? Um, well, you first identify the type of ML problem. Could be classification, regression, clustering. There are more, but let's start with the basic ones here. So we've mentioned these things earlier, but just to remind you again, classification is picking one of n labels, regression is predicting numerical values, clustering is grouping similar examples. That's the first thing you have to know the problem. And then you start simple. Normally you don't have to make use of very complicated models. The basic one is good enough in most cases. Don't overcomplicate things if you can. Yeah, and of course there's more stuff. But yeah, at high level, you just have to think of those things. Some limitations. I believe a lot of the limitations were already mentioned in the previous talk, but one important limitation that I'd like to point out would be generalization. So hmm, maybe you guys are familiar with this and ComSported, and this GIF perfectly um, showcases that example. So what are you seeing here? You're seeing different data points, different images. But if you get the aggregate statistic, they're all the same. And machine learning systems are also prone to this. If you're making use of the wrong features, um, you would end up with something like this. From the lens of your AI machine, they're all the same. There's also this problem that is present in AI systems. Who's familiar with this? So this is actually a very popular example from World War One, and they've done a study about the planes that survived, right? And they had this visualization. So if you see this, and the red spots would indicate the spots that were hit, right? What would you be doing? How would you reinforce the plane if you've seen this visualization? Interestingly, most people would say that you should be reinforcing the red spots. That's just how we think. Generally, that's normally what you'll be recommending. But in fact, that's the wrong way of doing things. If you reinforce the red spots, then the plane will not survive. Why is that? It is because the planes that did not survive are the ones who are hit in the spots that don't have red in it. It's counterintuitive, kind of. And that is survivorship bias. Correlation does not imply causation. So you have this in many ML algorithms. Yeah, of course. Well, this is using GPT-2, but you would see the same thing in ChatGPT some of the times. Of course, ChatGPT is more sophisticated than this, but I'd like to point this out because it still is present from time to time. Basically, it comes up with gibberish. So it says the solar system, yada yada, correct, more or less. Je ne sais pas means I do not know in French. But yeah, it will come up with some text. I have, for context, I have created this GIF back in 2019. This is blast from the past. I've been using the same GIF ever since. Um, Now look at 1 plus 1. 1 plus 1 equals 2 is not true, right? Of course, that's wrong. And actually, even when you ask ChatGPT, it will be honest that does not it is not capable of understanding mathematical concepts. It cannot do that, but it can answer some basic math equations or math problems because it's feeding it to another AI model that's specific to that. But anyway, for your typical LLMs, it doesn't really have that capability. Yeah, just more examples of that. The gibberish output. More limitations. So more fail examples of computer vision systems. So it detected that this one is a washing machine, but of course it's obvious to us that it's a butterfly. Um, and more examples here. What else? Like this one, it's a mosque apparently, but this is an academic gown. Let's check for more. It said that this is a rocking chair, but this is a fox squirrel. Just more fail examples. And this one, right? So is it a muffin or a dog? So just more fail examples. Yeah, what else? ChatGPT is fluent but not factual. Can come up with BS. Yeah, I'd like to end it with this message. So technology is a tool. Let's wield it well. This is from Benjamin Rhodes, was the um, defense secretary, I believe, when was the previous US president again? Yeah, Barack Obama. Yeah, before that, so from Barack Obama. And basically, it's up to us to be able to differentiate the various use cases wherein AI and technology in general is relevant. It's just a tool. It's really up to us on how we use it.